During inflation, the patch that was inflating was rapidly growing. It's hard to know what exactly you mean by velocity when the entire patch is getting larger, but you could imagine drawing a circle that describes the region that's going to become the visible universe today. And that circle was indeed growing during inflation at a speed which vastly exceeds the speed of light. And actually, the analogous thing would be true even without inflation. The speed of light would be greatly exceeded by the growth of the universe. That's allowed by general relativity because we view it not as motion through space, but rather as the expansion of space. In general relativity, like special relativity, there is an absolute barrier of the speed of light, but you have to describe it more carefully in general relativity. In general relativity or special relativity, if a particle starts at the same location as a light beam and has a race, the light beam will always win. In that sense, nothing goes faster than light. But if you have two places which are already separated, like the two sides of this sphere that represents the region destined to become our visible universe, the space in between can swell, and general relativity places no limit on how fast space can swell. So the distance between these 2 points is allowed to grow at a rate which is larger than the speed of light, and in fact, we believe it was much larger than the speed of light.